All right, so welcome. And as I was saying, on chapter 9, what we're going to be doing is we're going to be looking at the pregnancy data, but we're going to be applying a brand new model to this. These are going to be called ensemble models. And we'll just take each one of those decision variables and we'll look at it from a perspective of if a person bought that, are they more or less pregnant? But instead of doing a linear regression, we're doing these ensemble models. So kind of a different way of looking at things, just to kind of do the different models. So we'll look at bag decision stumps, and then we'll look at boosted decision stumps to see as another alternative to determine if someone is pregnant. And then we'll look at each one of these methodologies against the receiver operator characteristic curves to show the accuracy between the two. So just like we did before with the linear versus the logistics curves. So we'll be using this data from chapter 8. So in some things we're not going to redo like the whole dummy variables. We're just going to be like, yeah, you guys have that. So if we open up the sheet, it'll look just like it did before. We have ones where something is true and 0 if it's false, but the same data, male, female, home apartment, all the way through to buying maternity clothes and then saying if a person is pregnant or if a person is not pregnant. So what we didn't do in the last chapter though is this whole concept of dirty or incomplete data. So for the folks that took CSIT 120, we kind of talked about this. And the book gives us some recommendations on how to handle some of this data. So it might be that you do things like, if you have any missing values, maybe you just like delete that record or that row. So you'll basically be losing a little bit, but perhaps it might not be affect or bias your solution that much. If a column's numeric, then what you could do is you could potentially just look at the median of all those values and say, all right, we're just going to throw the median in. That'll kind of keep it, kind of in the center there. And why are we going to use median versus average? What from our whole central theory? What do you guys think? Why do we use median versus average? Yeah, exactly. Tell us more about that. I love that, Alex. So tell us more about that.
With outliers, the average can be skewed.
Yeah, exactly. What happens if we have, so for example, what happens if we have 1, 1, 10? What's our average going to be here?
Higher than 5.
It would be what?
Higher than 5? Or
it'll be 12, so it'll be 1 plus 1 plus 10. So we divide that by 3 and we get 4. So we have like 1, 1, and 10. So that doesn't really represent the data, right? So if we did this, it would be like what? It would be like probably if we did the median is going to be that middle value. It's probably going to be 1. Okay, that's kind of a bad example with 3. That's why you have to have something statistically significant. But that's why we say use a median versus the mean. And then what we can do is we could potentially even say, hey, if there's a row that's missing some values, maybe you put like a 1 or a 0 on there to show that it's missing value. And that way you can kind of filter it out and say, all right, all these are missing data. So these are, and the book has a couple more, but it's just good to know as you're looking at data, it's not all perfect. I'm giving you guys pretty good data that's filled in and pretty complete, but in reality, that's not the case. Okay. Questions, thoughts? Everybody's good? All right, so let's look at what we're going to be doing here. This is that whole concept of bagging. So what we're going to do is going to look at each one of those features in our Excel. And we're going to call each one of those, we're going to be called a classifier. So for example, one of the classifiers we have is whether a person purchased folic acid. So what we'll do is we're going to call each one of these guys a decision stump, and then we're going to say, hey, as a person, just by buying this, we're going to say, are they pregnant and not pregnant, and then we're going to have an impurity based on that, and we'll basically get a whole bunch of these data and pull them together and look at different and look at like usually like the square root of the product, of the features, and then 2/3 of the data at least for bagging. So you know, this decision stump in this particular case is going to be, hey, did a person buy folic acid? And then we have what here? We have like this decision tree. That's going to be true. If they bought it, we're going to say they're pregnant. And then if they're false, they're not pregnant. But in actuality, somebody might buy folic acid that's not pregnant. And then surely there's going to be people that are pregnant that don't buy folic acid. So if you look at this, you're thinking, can this work? Or what are we getting here? So this is going to be what we're classify as a weak learner. So we're going to say this is a weak learner. If you just had one of these by themselves, it would not give you many results. But if you stack up like 17 or 18, like in this example, you could tie a bunch of these weak learners together to actually model the data that we want and get good results. So again, this whole node impurity is going to determine how often the customer record is incorrectly labeled based on that. So we'll look and we'll see that not pregnant impurity is 49%. And we're going to work through all this math in the next slide. And then a pregnant impurity is 4%. And the overall impurity is 44%. So even though we just classified these people as you know, buying folic acid or not buying folic acid, you'd think you have a 50-50 chance, but in actuality, we're able to take that 50-50 using this model and get it down to 44%. So we're 6% better than flipping a coin, essentially, is what this model is saying. If you get a bunch of these and tie them together, we're going to start skewing and driving that model into something that makes sense. So this next slide is kind of crazy on our brains. So it took me a couple of times to read this. So I'm like, all right, let me go color code this out so it'll kind of make sense. So if we look at this above, we're starting with no model. So that's going to be like this customer data up at the top and that little round bubble up in here. So if we look at this, we have 1,000 training records. And then we can say the probability in our training model is 50% they're pregnant, 50% they're not pregnant. So if you look at this, you have a 50% chance that they're pregnant, and 50% of the time you'll be right, and 50% of the time you'll be wrong. So if you look at that, that's going to be 25%. You have 0.5 times 0.5 for pregnant, and you're going to have 0.5 times 0.5 for not pregnant. So if you look at this, you have 100% minus the 50% of pregnant, and of those, you're going to get 50% of those right. So this is going to reduce to 25%. And then non-pregnant, you're going to have the same thing. 50% are not pregnant, and you'll get 50% of those right. So then if you look at this, with no model at all, you have 100% minus 25% minus 25%, you have 50%. Okay? So, and that makes sense. We said we started out with 500 pregnant, 500 not pregnant. You'd expect to get 50%. But now what we're going to do is going to show how that folic acid, by doing this simple weak learner model, that 50% is going to improve to 45% node impurity, which means that 56% of the time we're going to get it right versus 50%. So we get essentially a 6% improvement. And the way we do this is if we come down here into folic acid, we said that 104 pregnant persons bought folic acid, and then 2% of not pregnant bought folic acid. So if we come over here into our chart, then we can say that of the pregnant persons, we have, so not pregnant is going to be 396. And does anybody know where we get that 396 at? Over here, this not pregnant. So we start off with 500. And we said that how many persons that are pregnant bought folic acid? 104. So if we do 500 minus 104, we get down to 396. Because we're basically saying if you didn't buy folic acid, you're not pregnant. Okay?
So of the pregnant persons, 104 that are pregnant bought folic acid, and then 396 didn't. Okay. So even though there were 500 persons that were pregnant, this model said, oh, only, or it's saying that 394 aren't pregnant. Okay. Does everybody get that? All right, cool. And then as far as the non-pregnant, two persons bought pregnant. So if you have 500, so this is going to be our pregnant. This is going to be our not pregnant. And if we have 500 minus 2, because 2 of our not pregnants bought, then that leaves us with what? 498. Okay? So overall then, if we took 396, and if we added 498, that's going to give us 894, or roughly 89%. Okay? So that's going to be this not pregnant side over here. We just went through this guy over here. Now let's go look at the pregnant side. Of the pregnant side, how many of the pregnant persons purchased the folic acid? So we said 104. So over here we're going to do 104. And then we said 2 not pregnant bought folic acid. So that's going to give us plus 2. So this model is essentially going to say you have 106 pregnant. Okay? But in actuality, we have 500 not pregnant and 500 that are pregnant, which is kind of funky the way this model works. Okay? So then what happens is we add those two together and we get the 106, and if we round that up, that's approximately 11% right here. Okay, so we had the 396, so that's going to be the 500 pregnant that didn't buy, we came up with 396, and then we had the 500 not pregnant minus the 2 that did purchase, 498. So that represents 89, and then as far as pregnant, we had the 104 plus 2, so we're saying roughly 11% are pregnant. So if we look at this then, if we take 396 divided by 894, we get 44%. So that's going to represent the pregnant piece of that. And then the not pregnant piece of this is going to be 498 divided by 894, and this is going to be 56%. And then we're going to do the same thing we did before, 100% minus 44% squared minus 56% squared, and then we get a not pregnant impurity of 49%. So that's this guy right here. This is kind of like the crux of this chapter. Once we get this, and like, yeah, we'll do all the Excel and it'll all make sense. So now if we look at the pregnancy impurity, we have 104 divided by 106, because we said, hey, of the, the pregnant is 104 plus a 2, so that's going to be 98%. And then we have 2 not pregnant over the 106, and that's 2%. And then if we take the 100% minus 98% squared minus 2% squared, we get 40%, or I'm sorry, 4%. So now what we do is we take our 89%, right here, this blue 89, so these are all color-coded, times our 49%, plus our 11% times our 4%, and we get down to a 44% node impurity. So that's how we get that 6% better. And your guys' brains are probably like, wow. It took me like 3 or 4 times to read this myself. Like, oh my gosh, it's like scrambling. So, but then I'm like, I'm just going to do this in colors, and it makes sense. Or at least it did for me. So hopefully, so does anybody have, can you guys kind of follow along with what's going on here? George, no, yes, kind of, sort of. So if I gave you a test, I said, this is the one problem you guys are going to have, and you pass the class if you understand it. And if you don't pass, who'd be willing to take that all or nothing, all in? Yeah. Well, yeah. And so essentially, again, what we're doing is we basically compare the customer data, and we just take 1 weak learner buying folic acid. But in this case, it's going to be, we're going to have 18 of these, like male, female, home, apartment, quit ciggies, buying wine, bought the body pillows, and everything else we had before over in here. So all these are essentially going to be a stump. And what we'll do is we'll create this model, and we'll look at 100 of these. So we'll take 4 at a shot, and then grab 66% of the data, and look at the node impurity. And we're going to take the randomly select these and take the best one and get 100 of these. We'll base our model based on that. All right. So again, if we look at this, we had essentially the person, anybody that didn't buy folic acid, we're saying they're not pregnant. Anybody that did, we're saying pregnant. And then for each one of those components, we look at the pregnant versus the not pregnant. Does that make sense? So if you look at this, we have the, you know, on this side over here, didn't purchase folic acid, false. We're saying not pregnant. And then we have to find the impurity of that, taking into account the pregnant and then the not pregnant. And then we get a composite not pregnant impurity. And we said anybody that did buy folic acid, we're saying they're going to be pregnant. And then we calculated out the pregnant impurity. And then we combined both those impurities together based on a weighted average. So 89% versus 11%. And then we came up with our average impurity over here. Okay. All right. So let's move on. So as we said, one single stump isn't going to be enough. If all you're doing is 6% better, that doesn't really move the needle that much. However, we're going to take into account all 19 of these features. We're going to make a stump out of each. And now if we take the 6%, you know, times like 19 and get that whole composite, now we start getting a model. And this is all going to be called bagging. So what happens in bagging is we're going to take a subset of the data. So of all those features, if we look at them, we typically take the square root of the features. So but as a whole number, so if we said we have 19 features and take the square root of that, what do we get? So if we take the square root of 16, what's that equal to? 4. If we take the square root of 25, what's that equal to? 5. So we know it's somewhere in between here, and we'll round down, and we're just going to say it's 4. Okay, because we take the square root of 19. So we're going to take 4 at a time. So we're going to do 4 columns, and then we're going to randomly select 2/3 of the rows. I'm going to show you how to randomly get 4 columns and how to randomly get 666 rows, and we'll do that 100 times. It sounds like it's going to be complex, but we're going to do this thing called a macro. If anything, you guys will learn how to do macro. Has anybody done a macro before? Yeah,
I don't remember.
yeah, but we're just going to record this thing and just let it rip. You're going to put a key and go bang, 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 bang. It's going to do this, all these like 10 steps, you know, 100 times just by pressing one button. So once we have many stumps created, now we can create this model. The book uses 200, but we can get by with 100, okay? Just because we're not. We'll try to make it a little bit simpler. All right, so let's get into the Excel finally. So let's go in. So I'm going to keep this guy here, bring this over, and then let's go into our data. And the first thing, so if we look at this, here's our test data. I'm going to move this down a little bit. So if you look at this, we have, just like before, we're going to have 500 pregnant and 500 not pregnant. And then we're going to take that and apply that to our test sets, just the same thing we had before. We're going to have 6%, 60 pregnant, and then 940 not pregnant. So what will be interesting is, once we're done with this model, we'll be able to take the receiver operator characteristic curve for bagged versus boosted. And I didn't think about this, but what we should do is even look back at chapter 8, once we're done with this, and compare that to the linear versus logistics regression and see which ones of the 4 are best. That'll be kind of something cool to do. So let's unhide the test data bag sheet. So right click and we're going to unhide the test data bag sheet. Okay. And then the first thing we want to do is in A1, we're going to type out equals random. So equals RAND, and then put the little things on there. And then once you get this guy, you're going to drag it, autofill it across over to S1. And if you guys want, you can even change this in from general over into number format, just so you have 2 decimal places. And then we're going to do the same thing for the rows. So starting in V3, you're going to say equals random. And then we'll make this a number as well. And then you can autofill that guy down. And you notice that these random numbers are kind of funky. Every time we touch it, just like we did before with the orange juice, they always update all the time. So how's everybody doing? Good? Anybody not there? Everybody's... Right, so to sort this out, what we're going to do is we're going to go into custom sorts. We're going to uncheck the My Data Has Headers. You're going to go into options and sort left to right. Then you're going to select row 1, and then you'll keep it in smallest, largest, and click on OK. When we do this, 2 things happen. One, the columns got sorted based on smallest to largest, but if you look now, you'll look at A, and that's like 0.89, and then B is 0.87, so it doesn't look like it's sorted. What happened is it sorted it based on the previous values, and then it updated all the, and then it randomized them again. So does that make sense? So it first sorted all the small to large in columns, starting in A and going to S, but and right after it did that, it just re-randomized the numbers. So it looks like it's not smallest to largest, but in fact it really is. It did that first, and then it re-randomized the numbers. Okay, so we have that. So now we could say we have our columns sorted out. The next thing we want to do is now we want to sort the rows. So to do this, you're going to grab from A2 and go over to column S. So A2 to S2. And then you can hit Control Shift and then hit the down arrow. And then that's going to give you all your data. Now notice we're not going over into the pregnancy data. Don't go over to U, just go from A2 to S2. And then you're going to hit the Shift, Control, and click the down arrow. Okay. The next thing we want to do is we're going to sort again. Let's go back into sort. Custom sorts. And then this time you have to do it a little bit backwards, but this time we're going to go into options. And now we're going to go top to bottom. And then once you do that, now you can recheck My Data Has Headers. And then you want to sort by the random value. Let's see, where's random at? Oh, I'm sorry. We have to go. I'm sorry, guys. We have to go from A2 over to V, all the way over to V2. Sorry about that. I misled you guys. So go A2. So let's read this and just do A2, and then go all the way over. So select all the way over to V. Okay, now you're going to hit Control Shift and go down. And then now we'll do our sorting. And then we're going to do options, sort from top to bottom. Then we're going to say my data has headers, and then we'll be able to sort by, if you go down, you'll see random down there at the bottom. So click random and do small to large, and then click on OK. So at this point in time, we've sorted our columns small to large to get the four, kind of get them on the left-hand side randomized. And now we did the small to large by row. So we first did the columns, and then we did the rows. Okay. So what we want to do then.
Wait, what did you sort by? For the column?
So the left column will be random. So we want to sort by the random column.
It just gives me like numbers.
Right. So then the next thing we want to do is we're going to unhide the random selection sheet. So I'll come in here and unhide the random selection sheet. You know, I'm so, it's like when you're putting together like a course like this, you're like, one of the things I thought of is like, what, instead of like having could you imagine like all these sheets that I'm saying unhide? These are ones I had to build, but could you imagine having, this isn't bad, having a room of 5, but if you had like a room of 24 people, like go build this sheet. I don't think you'd ever get off, go build this sheet. And then some of those formulas, I mean, it took me forever, unless you're copying and pasting them, it would take forever. So I kind of set this up, I thought, for success. So it's like, I'm gonna pat myself a little bit on the back. It's like that forward thinking helped. All right, so we unhid this. So now what we're going to do is we want to grab those first 4 columns and then the rows. So what we're going to do is we're going to, in A1, we're going to grab this formula equals TD bag A2. So what's this going to do for us? Anybody have any thoughts on that? So what's this formula doing for us?
Grabbing A2 from the TD bag.
Yeah, exactly. So this is nothing more than just a 3D reference. This is just saying, hey, go over in the test bag, because anything you see to the left of that exclamation mark means go over to that sheet and go grab the value that's in A2. And that happens to be, this first value is going to be that's going to be the feature, and then everything below this is going to be a 1 or 0 saying it's true or false. So what we want to do is we want to autofill from A1 over to D1. Okay, so these are going to be the 4 columns we look at, and yours are all going to be different than mine. We all had different values. They're all different. So I came up with 15, 9, 2, and 6. Alex, what did you have?
I had 17, 8, 1, 0.
Yeah, so they're all going to be random. So if you don't get the same numbers as me, you shouldn't. Okay. And then what we want to do now is we're going to autofill. Now, since we don't have numbers to the left or right, it doesn't know how far to go down. So we're just going to autofill down through D667. We're going to pull down. All right, and then we're going to 667. Then essentially what we've done here is we said go grab the column, the first 4 columns, and then their data values. And this makes sense because we said we have 19 features, and if you take the square root of that, that's going to be 4 point something. So we said, all right, we're going to pull 4, and if we have 1,000 rows, 2/3 of that's roughly 66.7. Okay. How's everybody doing? Everybody's got it? All right, cool. So now what we want to do is we want to get the pregnant values, and we're going to put that in E1. So over here, we're going to say go grab the values in TD bag of the U column, starting off with U2. Good band. Okay, so we have pregnant, and then now this time you can't autofill down because it could grab everything next to that. So here we go. So now we kind of have our data for our first little node impurity. And if we look at this, the next thing we want to do is look at our predictor and pregnant to determine if somebody is pregnant or they're not pregnant based on these scores. So if we look at this, our probability or possibility is, if you look at a feature, the predictor, it could be a 0 or a 1, and then pregnant can be 0 or 1. So if you look at this, so if you look at these data right here, like, you know, for me, column 15, I forgot what that one is, but if you look, that feature can either be 0, 0 or 1, and then the pregnant can be 0 or 1. So based on that, you have 2 to the 2, and if you count it down binarily, you have 4 possibilities. So you could have the predictor being 0 and pregnant being 1, predictor being 0, pregnant being 0, predictor being 1, pregnant being 1, predictor being 1, pregnant being 0. So everybody see that over there? And what we're going to do is we're going to look at this and do the ratios, and by us coming up with the ratio, we're going to be able to determine which ones of those items is going to be pregnant, whether it's a higher ratio of not pregnant or pregnant based on a predictor. And then we're going to do that impurity. So we're going to basically take that heinous formula we did earlier right here, and then we're going to map that into Excel formulas. And then of that, we're going to come up with the one winner. We're going to have the 4, and we're going to grab the one winner. And once we do that, we're going to do this 990 or 99 more times. But we'll do it with a macro, so you'll see it'll be like pretty darn amazing. All right, cool. All right, so what we want to do now is we're going to set I1 to L1 equal to A1 to D1. So you just simply say, in I1, you're going to say equals A1. And you're going to pull that over to L. So if you look, you're going to see I had 15, 9, 2, and 6, and you should see your 4 numbers there too. Does anybody not see that? Everybody's tracking still? Awesomeness. All right, cool. All right, so then what we want to do is we're going to use this formula called count if, and this is going to start matching the predictor to the pregnancy values. So for example, in I2, what we're going to do is we're going to say count if, and we're looking at A2 down to A667. That's basically, we're going to look at that column, and for each value in the column, we're going to say, hey, if A2 to A67 matches the predictor, and if E2 to E67 matches the H column, you're going to put a 1 in. And that's going to give us our all the combinations. And then once we get the total, guess what our total is going to come up to for each one of those for I2 to I5. Anybody have any thoughts? 666. Awesome. Alex, rock star. That's sticker worthy there. That's awesome. Good. So yeah, so let's put that formula in, and you're going to pull it through and pull it over. And then we should have 666, 666, 666, 666. And this is all going to be based on the relative weighting. So we always want to look at we're going to look at the A column, and then what happens if we drag this over? A2 to A2 to A667 becomes what if we go to the right? What do you guys think? So yeah, it's going to go to B. It's not locked down, but the 2's are going to stay the same. And then, but we're always looking at what? We're always going to be looking at the G column, but when we go down, the 2 becomes a what? So we always want to look at the A column against the G, but as you go down the rows, you want it to go from the predictor to predictor, and the same thing is going to happen for the pregnancy column. So we're going to look at that E column, and then we're going to look at the H compared to the pregnant or not pregnant, and then we'll count all those up using this count ifs. Gotta love that relative referencing, man. So we're going to grab this, and we're going to put this into I2. Okay, and then we're going to pull this over to L, and we're going to pull it down. Okay, and like Alex was saying, if we grab E2 to E5, my sum is 666. So we basically just found all the combinations of predictor 0, predictor 1, predictor 1, pregnant 1, predictor 1, pregnant 0. As we did this, each one of these is going to be 666. So the next thing we want to do then is we want to look at the ratio of pregnant versus not pregnant for those predictors, and then we're going to be able to figure out which value determines they're pregnant based on this ratio. We're looking at I2 divided by I2 plus I3, and then if that's greater than I4 divided by the quantity of I4 plus I5, then it's going to be a predictor of 0 versus a predictor of 1. So let's copy this formula in. And that's going to be in E6 or I6. Okay, so for me, the first 3 means that if somebody bought that product or did that, they're pregnant. And if somebody didn't in the last one, my L column, they weren't pregnant. Okay? So how's everybody doing? Good? All right, cool. All right, so now what we want to do is we want to go do those impurity calculations that we did before based on this data. So it's going to be the same exact thing we did here in slide 7 for each one of these stumps. So each one of these are going to be considered a stump. All right, so in I8, you're going to grab this formula. So it's going to be 100% minus okay, we're going to come up with a percentage. And we're going to copy the formula over to get the impurity for pregnant. And then we're going to get the combined impurity. Okay. And then we're going to drag this over. So if we, and then what we'll do is we're going to look at these 4 columns, and the one that has the least impurity, so you think about, would you want to have something with a lot of impurity or less impurity? What do you guys think? Is it better to have impurity or not have impurity? Less impurity is better, right? So if we look at this, which one had the least impurity? So for me, so all of ours are going to be different. For me, this is going to be 6. And if I look over into the test data, if I look over at column 6, that's feminine hygiene. So I guess for me, that was the best predictor for these 4 for me. So what did you have, Brian? 7? Okay, so 7, that's going to be folic acid. What about you, Brian? I'm sorry? So if you just look at if you go into the random selection, so you're going to find the combined impurity right here. Whichever one of these had the lowest value, you're just going to look at the top in row 1.
I changed the percentages.
Okay.
We got 4.
So 4, and then was it a 1 or a 0?
1.
1. So if you look at 4, that's going to be somebody bought so 4 and yours was a 1?
Yeah.
Yeah, so if somebody bought a pregnancy test for Brian, then that was, of those 4, that had the lowest impurity or the best score. What about you, Alex? 8. 8. So that's going to be prenatal vitamins. George?
17.
So were they both the same exact value?
No, we're looking at the lowest one, right?
Look at the lowest impurity, and then you go all the way up to the top to row 1, and that'll tell you the number. 17, so that's buying wine, so that's probably a 0.
Yeah.
Yeah, so that makes sense. So what that means is for George is wine was 0, so if somebody didn't buy wine, that means you're probably pregnant. Okay, what about you, Anthony? 5, and was it 0, right? So if you're not on birth control, you're probably more likely to be pregnant. Pretty crazy. But now what we're going to do is lather, rinse, repeat. So let's go find out. So now we could use some cool formulas. So instead of doing that by our eyeballs, what we could do is we could do these funky formulas over here to figure out using index. So if we look at this, we can use this formula here. And if we look at this formula, it's going to be, to find the winner, it's going to be look at E1, look at I1 to L1. And what we're going to do is it's going to be, so the way this index works is look at those values, and then the next two values, the 0 is going to be the row, and then the match is going to be the column. And if we look at this, we're going to look at the minimum value between I10 to L10, and then we're going to come up with that value, and then that value is going to be, and we're going to find the match of that, and we're going to put that in. So that match is going to give us the place in order, so it's going to give us row and not column for those guys, and that's what the I10 to L10 means based on that row, but no columns down. So what this formula is going to do is it's going to say, look at this, find the lowest value, whatever that match is, and for me, it's going to say the match is 4, and then you take that value, and then if I look at the top between I1 to L1, it's going to go 0 columns or 0 rows and 4 columns over, so it's going to put a 6 in there for me. So I'm going to scrape this formula and put this in a 1. And then the pregnant, so if we look at, so it's going to be the same formula, but this time instead of turning the value from I1 to L1, we want to return the value from I6 to L6. And we're going to put that in. So if all went well, whatever your lowest number is, whatever your lowest number was in the impurity should be the row 1 value you have, and then that correspondence pregnancy value. Does everybody have that? Anybody not have that? Everybody's good? Okay, awesome. All right, so we're going to do this one more time. So the cool thing about this is every time you go into that test bag sheet, it's going to automatically randomize the numbers for us. So all I have to do is go out and sort that. But what we want to do is we first want to copy what's in O1 to O2 and paste that value into P1 to P2. So you're going to grab O1 to O2, and then right click and paste the value, the little 1, 2, 3. Then now we'll be able to go sort back in, and then we're going to update that with a new number. Pretty crazy. Okay, so let's go back into the TD bag. So everybody has that, and they copied the values over. Not the formula, but the values. That's going to be key. So everybody's good, George?
So copy those two and then paste those values.
Yeah, so copy O1 to O2, and you're going to paste it into P1 as values. Everybody's good? Awesomeness. You good, George?
Yeah.
All right, perfect. All right, so let's go back into TD bag, and let's go lather, rinse, repeat what we did before. So somebody walk me through how we're going to sort out the columns. What are you going to do there? I'm sorry? So do we have to grab anything first, or what do we have to highlight?
A1 and 2 to S1 and 2.
So we're actually going to grab the whole columns. So grab from A over into S. Okay, then what? So what do we do next, Brian?
Sort and filter.
I'm sorry?
Sort and filter.
Sort and filter, good. So we're going to go sort and filter. Then we're going to go to custom sort. Then what?
Uncheck my data has headers.
Uncheck my data has headers.
We sort left to right.
We sort left to right. So where are we going to find that at? Options. And then we're going to sort left to right. Good. And then we're going to sort by row 1. Okay, so that makes sense. So row 1 has all of our random values in here. So we're going to sort by row 1. And we're going to click on OK. And then those existing values in there are going to be sorted, but then they're going to re-randomize. So it's going to look like it didn't sort it, even though it did. All right, so somebody else walk me through the next one. So now we want to sort by the rows. So how are we going to do that? So Ryan, why don't you walk us through that one?
A2 to V2. So grab A2 to V2.
Going to grab A2 over to V2. Good, awesome, Ryan. Then what?
Control Shift down.
Control Shift down. Awesome. All right, then what?
Custom sort.
Custom sort.
Top to bottom. Sort top to bottom.
Okay, so we're going to go into options and we're going to go sort top to bottom. Awesome.
I check my data has headers.
You guys are rock stars, man.
Then sort by random.
Awesome, very good. Sort by random, smallest, largest, and click on OK. All right. So let's go back over into random selection. And once we do, we're going to see that we have 4 brand new values over in here. And then if you look down at the lowest impurity for me, that's the 0.453. So that's 5. And then the value which indicates pregnancy is 0. So you'll see that this filled it in right here. Pretty cool stuff. And then I'm going to go over into the TD sheet. And for me, that's birth control. So if somebody didn't buy birth control, oops, you could be pregnant. What did you have, Brian?
I'm trying to. It won't give me the random option when I sort. Top to bottom.
All right, hold on a second. All right, so what did you have, Brian?
I had winners 8.
And 1. So 8 and 1. So if somebody, so if we look at 8, that's prenatal vitamins. And if somebody bought prenatal vitamins, we're going to say they're pregnant. How about you, Brian?
18.
18, okay, and 18 is probably a 1. So if they bought maternity clothes, probably pregnant. George? 7, that's going to be folic acid. That's going to be 1 if you buy folic acid. Anthony? 18-1 bought maternity clothes. Alex?
17-0.
17-0. So if you're not buying wine, you could be pregnant. So it's kind of craziness, isn't it? So we do this, and you get these 4 stumps. You randomize this, and you do that. But now we have so now we basically have 2 dots in here. We have 2 dots. We have 1 dot and 1 dot. Okay, so here we have no idea. Guess what we're getting ready to do? We're going to get ready to fill in 98 more dots, and then we're going to be able to get some lines through that then. Pretty sane. So we have a new winner. Yay. All right. So we look at this, then we have it saved. So if we want to, we can do this 198 or in our case, 98 more times. I don't necessarily want to do that. What I'd rather do is create a macro. And once we create the macro, I'm just going to hit the button 98 times and it's just going to do everything for us, which is pretty insane. All right, so let's go create a macro. We're going to create a macro. So to create a macro, what we're going to do is you're going to go up into the View tab. And I'm going to put, so make sure you're on random selection sheet first. So View tab, and then you're going to hit Macro, and then you're going to hit the Record a Macro option. And then for us right here, let's call this macro get bagged stump, and no spaces. And then let's just call this Control M. So every time we hit the Control M key, this is going to do exactly what we record. So this will be pretty insane. Okay, so everybody has get bag stump, Control M, and now we're going to hit OK. And now we're going to go record our macro. Now we're going to go record our macro. All right, so go back into macros and hit stop recording. So everybody hit stop recording. Okay. So what we want to do is we want to create a new column where P is at. So you're going to right click P and you're going to click insert. And then you're going to copy O1 to O2. And then you're going to paste value into P1. So you should see your first one, and I should see, for me, I see 50 on mine. Okay, everybody has that? All right, now let's go back into our view macros. Okay, then hit escape so you don't have the marching ants in there. We're going to hit escape in here. Okay, so you don't have the dancing little bar thing. All right, so now let's go into macros, and we're going to view macro. And just to be clean, let's delete the macro and recreate it. That's going to be the safest way. So let's delete this guy. Then now let's go create a new record a macro. And then again, call this get bag stump. And then Control M. And then click on OK. All right, so everybody's here? All right, cool. So now what we're going to do is we're going to go in and record our steps. So the first thing we're going to do is we're going to go into, click the TD bag tab. You're going to go back into TD bag sheet. So everybody should see TD bag now. And then let's go, and we're going to just do the steps we did before. So we're going to grab column A through column S. And we're going to go into custom sort. We're going to uncheck my data has headers. Options, sort left to right. Click on OK. Sort by row 1. Smallest to largest, and click OK. Okay. Then we're going to grab A2 over to V2. Then Control Shift, arrow down. Then we're going to go into custom sort again. Options, sort top to bottom. Okay. My data has headers. Sort by random. Click on OK. Now we're going to go back over into the random selection sheet. And then now I have a new value. I have 17, 0. So you guys should have another new value in there. Sometimes you get a repeat. That's fine. You're going to right-click P and insert. So we're going to create a new column. And insert. And then you're going to copy O1 to O2. And then you're going to paste special values or paste values. And then you're going to go into view, macros, and stop recording. Okay. Now, strap on in. So now we have this. You can expand this guy all the way out. And then I think we want to go out to column. We want to go all the way out to column DJ. But in theory, what you guys should be able to do is just hit Control M and just start clicking. And it's going to do everything we just did.
Yep.
So just hit Control M like a bunch of times.
Disgusting.
Isn't it?
Yeah, it is crazy.
And you'll let it go, and it's going to do a bunch of these. We'll see how far it gets.
Just hold on Control M and just switch it.
All right. Hold on, Ryan. So I'm going to go over, and then you're just going to look over to column DJ. So I didn't make it that far yet, so I'm going to hit I'm going to hit this a couple more times. So if you did, that's fine. Just if you got overexcited because you're doing macros like big dogs, then just clear out everything from to the right of DJ over. So yeah, I got a little overzealous here too. So I'm just going to grab DK over and then delete that. But that's insane because now if you go look at the, so if you just highlight like DJ 1 over to O, what's your count down at the bottom? 100. Here you guys go. So we could have did that whole thing sort like 98 more times or just a macro. I'm off in the macros.